welcome back to another Daishinfinity video. In this video, I will talk about the Height Theorem proof, which states that the h, you see the h on the inner side of the triangle, the h squared is equal to p times q, where the whole triangle is a right triangle. So in this video, we're going to talk about the derivation and the proof of this one using a different type of field in mathematics. Now the important part of this is that A, B, and C, let's take A and B and C, that C is the hypotenuse of the right triangle and A, B are different types of sides. Now if we would take a side perpendicular staying on the side of C and pointing to this intersection between the side A and B, this is the height of the triangle. We can normally say that the height, or like the area of the triangle here, can be A times B, or it can also be C times H of C divided by 2. So O divided by 2 you'll see here. And yeah, we can also take B and the H and the height of B divided by 2, and A times the height of A divided by 2. Now, mathematicians thought about dividing the hypotenuse into 2. So let's take a side P and another side Q, combine, and let's say that P plus Q is equal to C. Okay? Now, I'm going to prove this formula with using a triangle, but using linear algebra. So we're going to use some vector analysis. So let's take, for instance, B, to let it be equal to this vector. Okay, so it will be the absolute value of the vector, which would be the side of the B. A will be this vector. I'm going to call it U, the vector U. I'm also going to call C the vector tau, and I'm going to tell you that we want P to be equal to gamma and Q be equal to this vector. I'm going to call it gamma 2 because it looks like gamma. Now, as you see, I'm going to put in the vectors. So let's say this is B, it's pointing at this direction, U is pointing at this direction, and the Q, let's say Q is over here, so it's like this, and gamma is going to be like this. Okay, now since this is the endpoint of gamma 2, I'm going to make another line here, which would mean that F, let's call it F, the height would be the absolute value of the vector F. Now, since we have these informations, we can start talking about the ideas and what we see here and what we can derive from this image. Over here, we see that U is equal to gamma plus the negative of the F, which means we can say that U is equal to gamma minus F. We can also say that B is just equal to gamma 2 plus F, which means we already have two different formulas. Now, since we have two different formulas, we can still state here that over here, since we had a right triangle at the top, this angle here is 90 degrees, which means when we have a perpendicular vectors pointing at one another, we can also say that U times B is equal to 0. But U is gamma minus F, so we can say gamma minus F and gamma 2 minus F. Okay, now we can state that 0 is equal to, now we're going to use the distributive rule in order to, get rid of the parentheses. So gamma and these ones, I'm going to call it gamma and gamma 2 minus gamma F minus F. Oh, I made a mistake. The gamma 2 plus F, so it should be gamma 2 plus F, so it will mean gamma plus gamma times F minus F times gamma 2 and f times f. Since you see over here the gamma and f and the gamma 2 times f over here, if we look at the vectors gamma and gamma 2, they are perpendicular to f, which means we can put the f over here and we can say that it's a perpendicular line. So gamma 2 times f is 0, but also we can say that gamma times f is 0 because gamma and f are also perpendicular to one another. So we can say that these are 0. Okay, so we're going to say that these cancel out. We're going to bring the f times f on the other side, and we get f times f is equal to gamma times gamma 2. Now this is a very important thing we have to notice, and this is a scalar product. So if we would take the scalar product of two vectors over here, which would be the same vector, let's take the same vector f and f, it would mean that we take the cosine of the angle between these two, which would be 0 degrees, times the length of the first vector times the second vector length of the second vector. Cosine of 0 is 1. So we get 1 times this, which would mean we have the square of the length. So we say is the square of the length is equal to the length of the first, so p. Okay, I think and I hope it's p, and the other gamma 2 is going to be q. And as you see, the length of f is h, so we have h squared is p times q. So let's write it again. Through these observations, we got that h squared is equal to p times q. So now we have proven that if we would have a perpendicular, the right triangle over here, and we would have h here, then the square of the side, the area of the square, is the same thing as taking this side, and let's take this side and put it here. Okay, I'm gonna put it down here, so that these two areas are the same. Now in the next video I'm going to prove that the areas of these two are the same geometrically, and I'm going to prove it in another way. In this way, in this video we talked about the linear algebra proof way. So I hope you like this video, and if you like the video, please subscribe and like and comment, and we'll see us in the next Daishinfinity video. See ya.